If we will start launching rockets with satellites on to the east, we're going to have a fine problem with our neighbors, Iran and other Iraq, which are east to us. Deep tech has many definitions: tough tech, hard tech, and I like the hard tech definition because it's focused usually on hardware and it's hard to achieve. Space environment is harsh. We're talking about temperatures going up and down from 150 Celsius to minus 150 Celsius in space. We invest usually in pre-seed seed startups, which means we are usually the first check.
Right.
Our checks are about somewhere between $1.5 to $2 million.
Welcome to another episode of IsraelTech. I'm here with Assaf Wise, the CTO of Earth and Beyond Ventures here in Herzliya. How you doing, Assaf? Thank you for having me.
Thank you for coming here.
So first, let's just jump right in. What is Earth and Beyond Ventures?
So Earth and Beyond Ventures is a venture capital that invests in pre-seed seed startups here in Israel. We also, together with the Innovation Authority, the Israeli Innovation Authority, the IIA, we invest together in pre-seed startups within an incubator that is focused on deep tech technology and also space technology, which is, I would say, quite a new focus within Israel lately.
I definitely want to spend some time on space, but first about deep tech. What's the difference between tech and deep tech?
Deep tech has many definitions. One of them is like tough tech or things that are hard tech. And I like the hard tech definition because it's focused usually on hardware and it's hard to achieve. Usually deep tech are technologies that are based on research, patents, things that you cannot overcome by bringing more people who will program faster than the other company. Those are ideas that take time to get from the point of the possible solution to the actual solution, to the manufacturing, because there is a lot of science behind it. So that's where we are focused. So, and it's also a matter of time. Like when you look at a company like Mobileye 15 years ago used to be called deep tech because talking about algorithms running on microchips which are not energy driven CPUs, control processing unit, like a computer. So that used to be like a dream, doing all those computer vision on such a small chip. So this type of dream, I would say it could be called back then as deep tech. Today, where everything is obvious, you know how to do it correctly, it became high tech. It's not anymore deep tech. So I have a friend, Barak Ben Eliezer, who is a good friend of mine since I was young. And he is a partner in another VC called Deep Insight. He has a very nice way of calling deep tech the point where there is a drop falling from the sky towards a very calm pool. And deep tech is the moment where the drop is just before hitting the water and creating those waves that changes the whole pool. So deep tech is a technology that will change the whole pool, will bring ripples into the pool, yet it hasn't been there. When you look at it at first, it looks like a dream, but once it hits the water, it changes the whole environment.
Would it be safe to say anything that's not software basically is deep tech in a sense?
Yes, but still, there are many things that are not solved within cybersecurity and other type of tough problems we have. We're talking about more into materials, hardware, optics, things like that are more tangible.
Mm-hmm. So what about space technology? So Israel's not known for space technology.
Well, actually,
you may think so because you're living in it, you're in a bubble, but I think the people I speak to, when you ask, what is Israel known for? And you ask them to name, let's say, even the top 10 things, top 10 industries, I don't hear space. So I wouldn't put space up. So I wouldn't put space up there as one of the leading ones. You claim otherwise. One, why do you think there's a misconception? You can briefly answer that. And then maybe you can talk about what does space tech in Israel look like and how it's different from other countries and what are our goals within space technology?
Sure. So a few fun facts. Israel is the 8th country in the world that managed to bring a satellite by its own to space. The Assaf Wise satellite at the beginning of the 90s, if I remember correctly. That is a breakthrough. All other countries that manage to do that are real empires like Russia, China, Japan, US of course, yeah. And Israel is the 8th country to do that. Israel is the 7th country to reach the moon. A bit too fast, I might say. Yeah. A bit too fast.
We crashed on the moon.
Yeah, we crashed, but reaching
the moon.
Reaching the moon is not an easy thing to do. The US, China, India, they've all crashed into the moon before managing to land on the moon. So there's nothing to be ashamed of. Actually, we were the first private company that reached the moon. So how come Israel is not considered to be a space technology country? That's easy. We're focused within the defense area. So all our space ecosystem, or most of our space ecosystem, is focused there in the defense area. While places like the US...
Unlike exploration.
Well, we don't do exploration. We are focused on what's good for our defense, what's good for our country. And we do not, well, we do have exploration, but we are doing it together with other countries. We collaborate. So there are many projects, telescopes, missions that we are part of, but we're not leading. In order to lead such a venture, it takes a lot of money, which Israel is not a super rich country, but definitely Israel has a lot of knowledge in space, so we can assist in many subcomponents or systems. So Israel is a major space technology center, but focused into defense area. When you look into the US, NASA used to be focused, NASA, which is a government agency, used to be the focus of space within the US. So you can say US has done a transition from moving the space technology from being governmental into going into SpaceX and to other companies which are commercial. And that's a transition we believe Israel is about to do in the next few years. And actually we're helping it to happen, because we as a VC try to invest in commercial startups that have viable technologies both for space and both for Earth, and we can talk about it later. And we believe that the knowledge we have here about space technology, space subsystems, and space components is super valuable for the world space economy. So yes, Israel has space industry focused on defense. And you know, something quite amazing. All countries launch to the east for a very good reason. The Earth turns around.
Right.
And well, if you want to have the kinetic energy coming from the Earth turning around, you should launch together with the Earth's rotation around itself. Now, if we will start launching rockets with satellites on to the east, we're going to have a fine problem with our neighbors, meaning Iran and other Iraq, which are east to us. So Israel is the only country in the world that launches west against the Earth's rotation. That means for a given launcher, a given rocket, the amount of payload we can put on to get it into orbit is much smaller.
How much smaller?
We'll get into that. Like if you could launch half a ton using a certain rocket, we can only launch a few hundred kilos.
Wow.
So we had to make all our satellites much smaller compared to other countries. So all the miniaturizing of satellites.
The reason I had to make them smaller, so they'll be lighter, so therefore we could have.
So we could launch them to the west.
Right.
And actually, when you look into the map of satellites, you'll see all satellites are rotating one way, and you see a few crazy satellites going in the other directions. Those are Israeli satellites.
Yeah, that shouldn't surprise anyone.
Yeah.
If someone's doing something weird.
You know the joke where someone calls his friend and he tells him, you should be careful when you're coming back home. There's a crazy guy going against the direction of the traffic.
Yeah.
And so he tells him,
one.
There's so many right now. Yeah. So that's our satellite.
Amazing. So let's talk about specifically the defense within space. What are the different? If you were to divide, what are the different components that Israel's working on when it comes to space defense? Well,
Israel has technology from starting at the launchers down to the subcomponent. Israel is building imagery satellites, radar satellites, which are called SAR, synthetic aperture radar satellites. Israel is building communication satellites. We have all the capabilities for all the technologies within the space industry. For commercializing our technology, I would focus into small satellites, subcomponents, communication, imagery. That's where we're strong. That's where we are strong. Meaning, when we go into launchers, there are more advanced technologies out there. The reason Israel didn't go into that technology is because it requires a lot of capital, and we had a solution that was good enough. So, having to export the knowledge of long-range launchers that can go into space, that's classified information. So you cannot share with any type of country you'd like to work with. So it's easier for us to talk about and to work with other countries commercially on the payload. The satellites themselves, the technology within the satellites, and so on. So yeah, I would say that's what we can offer. And when we're talking about subcomponents, we can talk about detectors, we can talk about all kind of high-speed modems, all kind of special antennas that can deploy in space. New type of materials that can withstand space environment. Space environment is harsh. We're talking about temperatures going up and down from, well, I don't know the Fahrenheit table, but from 150 Celsius to minus 150 Celsius in space. You have oxidation done by free oxygen, like atoms in space, that oxidizes everything around them, which is really tough to all kinds of materials. So and of course vacuum, okay? You have vacuum outside there, which is very tough to many type of systems. So definitely Israel has all the knowledge how to cope with this type of environment. We have all the technology that we can bring into that ecosystem. And of course, Israel has done that already. So we have systems up there working. And that's a big thing, just like the defense industry. The reason why the defense industry in Israel is good is because we had those things working and we learned a lot of how to operate them correctly. What is needed, what is required, what is not required. What should we specify for our next future system, and what can be neglectable it's not really relevant for the next warfare or wherever we see as a future defense requirements. So being in space gives us a great advantage. Yeah, that's about it. Did I answer your question?
Yeah. No, you did. So when I'm thinking about kind of obviously defense, people are thinking of course, Iran as an example. How do we counter them? Obviously, people think about intelligence collecting, but also, of course, communication, not just on the ground, but also they're also used to communicate, I believe, even rockets and for the Air Force. Is that correct? Do we rely on space in order for our Air Force to communicate too, correct?
Well, I wouldn't go into that area because it's a classified thing of how do we communicate with our forces. But of course, you can imagine that just like Starlink enables communication all over the world, I would assume that if we have satellites that have communication capabilities, it will enable us to communicate. Mm-hmm. But you don't need Israeli satellites for that. You can use off-the-shelf standard communication equipment for that. So if Israel has the capability, I assume we do, definitely. Do we do that? I guess it's classified.
Okay, fair enough. How many satellites does Israel have in space?
Oh, that's a good question. To be honest, I don't remember.
I know we have many, but they're small.
Yeah. So I would guess at the order of magnitude of 10. It could be 20 or a bit less. But the lifetime cycle of a satellite is about 5 years for a low Earth orbit satellite. After 5, you usually plan it for 5 years. I can say that I think Israel has, I don't know if it's a world record, but one of our satellites that was intended to be for 5 years is still running today after quite a long period of many years in space. We've managed to extend the life of satellites much more than we expected.
How?
Building things reliably. We build it correctly, and we take extra caution, and we, for every route for a certain current to go through or communication line, you have redundancy that enables you to switch if there is a component failure and so on. We build things correctly, and there's a lot of experience in that in Israel, from building systems for the defense industry, which have to keep working, being reliable. So we took a lot of those disciplines and put it into our satellite systems, and it works.
Let's talk about Earth and Beyond specifically. Let's talk about it. You invest in startups, correct?
Yeah, we do.
Specifically in deep tech and space. Let's talk about the space for tech for a minute.
Sure.
What do you look for? Where does this talent usually come from? Because even though we may have a lot of know-how and knowledge, it seems like it's overwhelmingly concentrated, working for the government, either directly or through contractors. Where is this knowledge pool? How come I'm not meeting these, when I go to deep tech events, I'm not meeting people doing things in space tech as an example, and these startups? How do you find them? How many are there? Like, how do they exist? Like, where's their ecosystem? Do they have one, or are you building it?
So, first of all, you're not going to the right events.
Okay. Well,
you should come to our events.
I'm looking forward to the next invitation.
Okay, sure. You're always welcome. So definitely there are space events here in Israel, and you see a lot of emerging space tech here in Israel, commercial meaning, and definitely a lot of people are focused on standard deep tech because space tech is still difficult. The market is not big enough in Israel, and most of the market is in the US or Europe. So if you'd like to meet Israelis that work in space tech, go to a convention in the US or Europe and then look for the Israelis. So we do have technologies, we do have people that work on new startups. We mostly find those people, I would say the majority come from the defense industry, either from Rafael or IAI, which is the Israeli aerospace industry. People coming from the 81 unit, which is not a space industry unit, but it's a deep tech unit with people who have understanding how to build things that can withstand space environment or can be very reliable. And those who are also space enthusiasts, they go into the space tech. So we have startups coming from all those places. And of course, you have other people, normal people who are into space, are enthusiasts who love to work, would love to work and bring a change into the new space environment, which is right now exploding because what Elon Musk has done in the amount of launches and the price of launches, which are dropping today. And there would be they have the basic knowledge, and there are courses in universities of how to build space devices and so on. You have professors working on building new type of thrusters for space satellites, and you have people working on how to build electronics for space environment, and people working on new type of mechanics for antenna deployment and so on. So you have this knowledge in universities, and you can have new ideas which you'd like to implement in a new company, and those people are out there and looking for somebody to invest in them in order to create to bring the idea, this dream they have, into reality.
How much would you say the checks have to be written for space startups?
Yeah.
Do they have to be bigger checks? I mean, I'm assuming because we're talking about hardware, the technology, it seems far more expensive than a lot of the software, or even cybersecurity and AI.
Yeah.
Well, not necessarily AI, actually. How much bigger are they talking about? How big are the checks that you guys write?
So we invest usually in pre-seed, seed startups, which means we are usually the first check.
Right.
Our checks are about somewhere between $1.5 to $2 million.
Those are your pre-seed checks?
Yes.
Those are pretty big for pre-seed.
Correct. Because, as you said, you need to build something real. It's not bring a computer, bring a chair and a screen, and you start working. Usually you need some type of labs or equipment and so on, but we help our startups. We have a laboratory filled with equipment for them to work with, so they don't have to spend all their funding on CapEx, meaning all kind of systems to check and test and build their devices. We have collaborations with other labs around Israel to help the startups to bring their idea into reality and to build something or invent a new type of chemical or build a new type of technology and so on. So there's a lot of enablers within the Israeli ecosystem, like labs and facilities that enable startups to work with small money and create what usually would cost them a lot of money. Like we have one startup that wanted to build their own lab, but we managed to get them a very good contract with a laboratory that is located within a university, so that they don't have to spend such a lot of money as they would have if they wouldn't have this type of contract with the university. So that really helps those startups to begin. Now, in the long run, definitely those startups will require a lot of money, in order of magnitudes of tens, if not hundreds of millions of dollars. But I would say also a successful cybersecurity company would require this same amount of money, because that's the numbers which you usually see running around. So definitely deep tech is more difficult than any type of software technology, but it is achievable.
How has the government been supportive, and have they maybe gotten in the way or when it comes to space technology? Actually,
the government is amazing. We are VC, and we won this bid that the IIA, which is the Israel Innovation Authority, we won the bid, and we've constructed together with them an incubator for space and deep tech technology. So they are really helping by pushing forward this aspiration of having a viable commercial space ecosystem within Israel. We also collaborate together with ISA, which is the Israeli Space Agency, And they also help us spread the word around the world about startups working in space. And we have managed to make many events all around the world with them, exposing the Israeli commercial space industry. So definitely the government is really helpful. We work in close collaboration with them. They help us build new facilities, fund new labs for those type of needs. And I believe that they will keep on working on that and will enable more and more startups from having this capability that they would like to create or implement, and which would be considered at the beginning as impossible because it will require a lot of funding. But by establishing this ecosystem of incubators and labs and facilities, this way those dreams can be they could become into reality, because you don't need such amount of money to create them once you have all this infrastructure.
What's the kind of investor that would invest in space technology and what you're doing in Earth and beyond?
So, good question. I would say a brave investor. Space environment and space ecosystem in Israel is very young. A deep tech ecosystem is very difficult. Our investors are deep tech companies such as Corning, Kyocera. We'll speak about those companies in a second. And also Spacecom, which is a space communication provider here in Israel. And also the Rhodium, which is a more financial investor, which is the family office of Daniel Recanati, coming from the Recanati family, and more. And they, when we did our roadshow explaining about our belief that Israel has all the required knowledge to push forward the space ecosystem, the space commercial ecosystem, we managed to convince them that Israel has the knowledge and the capability, but currently everything is into the defense industry. And we believe also that the deep tech ecosystem here in Israel is something that can be pushed even further. And we invest in those very young startups that can bring new type of technologies, new type of subsystems, new type of constellations of systems into the commercial world. Now, it's something interesting because I keep speaking about deep tech and space tech and keep bouncing between those two. And the connection between those can be explained by our investors. So if you take Corning, for example, Corning is an American company, a huge American company that works they started in making glass. And during the beginning of the space industry, well, it's not an industry, it's space quests. I'm talking about the 1950s in America. There was a request for building those windows that can withstand very high temperatures for the Gemini project and then the Apollo project, which reached the moon. And Corning won the bid. Corning were the only one who had the technology to build the helmets which had glass on them for the astronauts and so on. And they had this special technology for building this very harsh environment glass. So that was a space industry product. Now, during the 80s, the British came to Corning and told them, look, we have this new type of technology called laser. And we'd like you to make a pipe made out of glass that could have this laser put inside it, and we'd like it to be super transparent so that the light will come from one side and will go out from the other side with minor losses of light. And Corning told them, no, we don't have this type of technology, bye. And they came back and told them, look, we couldn't find any other company that could do that, and we believe you can do that, so maybe try and think again. And Corning.
What year is this?
Oh, I think it was the 80s.
In the 80s.
Yeah. And Corning sat and one of the engineers there said, we have this space technology for building glass for spaceships. I think we can use this technology for creating what we know today as fiber optics. So Corning invented fiber optics through technology that was actually made for the space industry. So this technology coming from space is implemented today everywhere on Earth. And that's not the only technology for that. CCD, the detectors within cameras, was invented originally for space. Diapers for kids was invented for astronauts because they used to be sitting inside the rocket for hours and hours and they had to pee. The only way of peeing is peeing inside your suit, ruining all the sensors. So disposable diapers was invented for astronauts. Then it became a common thing for babies. Until then, you would use like cloth diapers. And there are a bunch of technologies that originally started from space and came back to Earth. Now, are there technologies that are coming from Earth, starting from Earth and going to space? Definitely. Again, Corning, when Steve Jobs decided he wanted to make a new type of phone, he came to Corning and said, I want this phone that has this look and feel of something very luxurious. And I want glass in the front and glass in the back. And I have this glass to be very durable. It can withstand scratches and so on. And Corning has that technology, Pyrex and all those kitchen plates that it's hard to break. And Corning said, okay, we'll do that for you. And that's exactly what created Gorilla Glass, which we know today as the glass that is in front of all our screens and everywhere around us. And that glass is like thin as paper and can be foldable. Today you can take a phone and fold it into two pieces, and the thing in between that the screen is stick to, that's glass. It's not plastic, it's glass that can be...
It's one piece of glass.
One piece of glass that can be folded into two. And Corning took that technology and implemented it into space. Where? And so where? The answer is for solar panels. Solar panels like for the ISS, which is the International Space Station. Instead of coming as big plates of solar panels that are folded one over the other, it comes as a rolled piece of paper with silicon solar cells stick to it. But it's not paper. It's not a roll of paper, it's a roll of glass. Because the silicon of the solar panel has to have the identical expansion ratio and temperature like to what it sticks to. And silicon is very similar in its parameters to glass. So they had to have glass, not polymers, not plastics, not nylon, glass to have the silicon stick to it. And they had to have something very flexible as a paper. So they took the Gorilla Glass technology and implemented it into space. So definitely technology bounces back and forth, and deep tech becomes space tech, and space tech becomes deep tech, and so there's amazing mixture of what's your market, and that's something we're focused on technologies that can be implemented both in space, but they do have a market here on Earth, and that besides in investing in pure deep tech startups.
Interesting. When it comes to deep tech, you were saying earlier that Israel, a lot of people think of Israel maybe more doing software than hardware, and deep tech you're saying is associated more with the technology and the hardware space. Are we good at this? Are we good at that? I don't really think of Israel as a manufacturing hub for anything. Why aren't we dominating in hardware?
So the fact is we are dominating in hardware. Most processors of Intel, Apple, all those big companies that manufacture processors, that's all designed and not manufactured. Well, for Intel, also manufactured here in Israel. The second biggest manufacturing facility for chips of Intel, if I'm not wrong, that's in Kiryat Gat here in Israel. Mm-hmm. The design of the chips is done in Haifa. Mm-hmm. And so Apple is just here. Mm-hmm. Design of many parts of their chip is done in this building next to us. Mm-hmm. And so definitely Israel is deep tech. If you look at the automotive industry, so when you think about Israel, would you think automotive industry?
No.
No. But Israel is one of the biggest hubs for automotive subcomponents, high-end subcomponents, like LiDARs, which are the radars that use lasers, like for all kind of high-end sensors, and for special materials, special polymers. That all comes from Israel technology. So Israel is definitely a high-end place for subcomponents, sub-technologies, subsystems for many industries. And that's all deep tech. That's all technology that comes from the defense industry, from universities, from research labs here in Israel.
Yeah, but we're not, would you say, but we're not like, we may be, let's say, strong in developing this hardware, but when it comes to manufacturing, we're not.
Well,
or in general manufacturing, it seems like we're not. I mean, there are some great exceptions, right? SodaStream, that's not that's hard tech or anything, but you do see there are some obviously companies doing well there. And as you mentioned, in Kiryat Gat, the Intel, their chips here. But I feel like, do you think we're going to see more manufacturing in Israel? Especially, I think onshoring has become a priority.
So we need to do what we're good at. And usually when we go to manufacturing, you have to be cheap, very cheap. Mm-hmm. So markets like India and...
Yeah, but robots are doing most of the manufacturing, at least now or into the future, don't you think? Which removes all of the costs, the labor cost differentiation.
So that's exactly where we're strong. And if you look at the Intel facility, it's mostly robots.
Right.
So that's why it's easy. It's robots that need to be controlled by very skilled people. Mm-hmm. And that's Israel.
Right.
So although labor here is much more expensive compared to China or India or other places, because you require very skilled people and because you only require a few people because most of the things are done automatically.
Right.
So Israel is a good place to build such a factory. But when you require more labor, then Israel has no advantage compared to other countries. Vice versa.
Right.
And I think we should stick to doing what we're good at.
Agreed. So you saw that you're on the board of 81.
Yeah, and then 81 unit.
The 81 unit, yeah. And you spent over 20 years in the Army.
Yeah. No, in the Army I was actually 24 years because I started in the Talpiot project, which is a 3.5 years project.
What's the Talpiot project?
Oh, well, that's a long question.
Okay. It's a short question. Let's make it a short answer.
Yeah, that's a long answer, actually.
What's the Talpiot project?
So it's a special project, considered to be an elite project, where during high school, the Army, the IDF, is looking for young people who studied physics, and they take them through, I think they start with about 10,000, 20,000 kids all over the country and start passing them through tests. Mm-hmm. And after a year or so of tests, they are left with about somewhere between, at my days, we used to end up as about 30 to 35 people entering this project. Today, I think the numbers are closer to 40 to 50 people because there is a high demand for people coming out of Talpiot within the Army and defense industry. So they increased the numbers. And then in that course, you do 2 degrees or even 3 in mathematics and physics, and in some cases also computers. And while doing those 3 degrees, during the 3.5 years in Talpiot, you also do paratrooper basic training. You drive a tank, you work with explosives, you do you navigate in desert and in other environments. You do anything, and you become an officer, of course, and you learn about all parts of the IDF, and they show you everything. And this way, by doing things, you understand better of what is required for the soldier, for the end user. So the goal of Talpiot is to create the leaders of the technology within the army. And after you finish this 3.5 years, you have to sign up for additional 6 years. So the total program is a 9-year program. And after those 3.5 years, of course, you go you go to all type of units within the IDF, and you start your actually career there, a 6-year career. I went to the 81 unit, which is the intelligence technological unit, which is more focused. Like there are 2 units, I would say. There's the 81 unit, which is more known for people coming, which is more known for deep tech solutions. And there's a 8200 unit, which is more known for their software and cyber capabilities. So there's a mixture, actually.
Is there a competition between those two? At least like a friendly competition?
Like any 2 groups within any environment. So yeah, of course there is. And especially because there is a mixture. It's not like the 81 unit is focused only in hardware and 8200 unit is focused only in software. So there's always competition, and competition is a good thing.
Agreed.
As I see it.
Yeah, totally.
But if you look into startups coming out of the 81 unit, people coming out of the 81 unit, and startups of people coming out of the 8200 unit, you'll see that many coming out of the 81 unit are more deep tech orientated, and many coming out of the 8200 unit are software orientated. And of course, there are exceptions for any of those 2. So I started in the optics area, moved on to be the head of the optics group, then became the head of one of the biggest, if not the biggest, projects within the intelligence corp. That was a very, very intense project where we had within 1 year to bring a solution that we had no idea how to solve, but we were being asked to solve it, and we said, okay, we'll do it. And then we came back to the unit and said, okay, how are we going to do it? and we had no idea. But we started, and that's something that's Israel. You do things because you have to. And you find a solution because you have to. You have no choice by finding a solution. Mm-hmm. And that brings you to the edge of your capabilities. And that's the point where magic starts appearing. Mm-hmm. When I was later on, after I finished, after I retired as a lieutenant colonel from the 81 unit, I went to be a CTO in this Dutch company that is built out of about 19 companies, subsidiaries. And we had a startup there that we were trying to aim and build a new type of cryogenic cooler for imagery, thermal imagery systems. And we had to reduce the price of this unit from, let's say, $2,000 to $500. And we had this amazing engineer, Alexander Vaprik, which I adore. And he this was his task. And he kept working on inventing a better technique, a better technology of how to make this device cooler cheaper, cryogenic cooler cheaper. And he reached the goal of managing to make it cost, the bill of materials to cost only about $500. And then the managers came to him and told him, okay, you managed to reach the threshold, $500 threshold.
Now 200.
Now make it 100.
I was going to say, right?
Yeah.
So Israeli.
And he said, I can't. I said, you have no choice. Otherwise it won't sell. And magic started happening. Like he was telling me, I was going to sleep, I was going to the toilet, I was going to shower, and all I thought was, how do I make it cheaper? And then ideas started coming and maybe changing the way the system works and so on. And when you have no choice, and so you come up with amazing solutions. Mm-hmm. And to be honest, when you have, Israel is not a rich country, and startups here do not have the funding that American startups have. But when you don't have enough funding, and when you don't have enough people to work with, so first of all, everything is within your head. So integration is easier. You don't have to make meetings in order to pass information. So there are less people, so everything is in one brain, and the solutions become more, I would say, complex, or because you're able to think about more complex solution within your own brain compared to talking with different people. You're more creative, and here in Israel, because we don't have enough money, you have to be creative with your solutions. And that's exactly our advantage of bringing new types of solutions, new type of creative solutions to the world. Now, it's not because we're smarter, it's because we have no choice. And exactly that's why we built smaller satellites, because we had no choice to build them smaller, because our rockets are launched to the other side.
To the west.
To the west, exactly. And all the energy of the rocket has to overcome this Earth's rotation instead of to overcome the mass of what it's carrying. So we had to build our satellite so smaller. We had no choice. We had no choice but to be the best army around with a certain amount of people. So we added technology into our army. We built the best tanks, we built the best rifles, we built the best rockets, we built satellites. We had no choice. The reason why we started the space industry is because we had to bring back the Sinai Desert to Egypt. And then we had a problem. We had the Egyptians on our border, really close to Tel Aviv, to Beersheba, to Ashkelon, to all those places which were Israel. We didn't have this desert that to protect us from invasion.
Right.
So we went to the Americans and we told them we need funding to create a space industry. And we need to build a new space industry in Israel and to build a new satellite that will look at our surrounding neighbors to make sure that nobody is preparing to attack us. Mm-hmm. That's how we started. That's how Israel's space industry started. We had no choice.
We could have not given back Sinai.
And then I think we have lost the ability to have peace with Egypt.
We'll see how that's going. So where do you see Israeli space in the future in like 10, 20 years? Should we just see more of the same, just maybe more companies, just a little bit better? Or do you think we'll see a kind of a leap?
Well, it's going to change for sure. I think we're going to see more and more commercial space companies here in Israel. I believe that today when you look what is the major space market of the world considering space, it's America. Okay, it's the US. But I would like that once Elon Musk decides to go outside of the US to look for new technologies, the next station would be Israel. I would like him to come here and understand that if he wants to have a cutting edge, new type of technology, come to Israel. That's my vision. And we're not far from that, to be honest. we have all type of new technologies emerging here, and the future, as I see it, is really bright concerning space technology and also deep tech technology. To be honest, we're not only investing in space technology, we invest also in deep tech technology, and the deep tech technology here is amazing. The amount of new ideas, breakthrough ideas, very novel ideas that I haven't seen in other places in the world. The number of those keep growing, and I'm quite amazed about what is the potential of this amazing small country.
And what about Earth and Beyond? So I'm assuming you'll just follow that. You'll be investing in these technologies, whether there'll be commercial or other deep tech that's necessary.
Sure. Yeah, we believe that we're going to grow. We are already growing, and more people are interested in being LPs, meaning limited partners, investors within Earth and Beyond, or cooperating, co-investing with Earth and Beyond here in Israel and abroad. And we definitely see more and more interest within the deep tech economy here in Israel. And Earth and Beyond is a part of this community, part of this growing community of deep tech and also space tech technology. I see a bright future for us there as well.
As people want to stay up to date with Earth and Beyond and with you, Assaf, where should they go?
Oh, well, we have our website. It's earthandbeyond.ventures.
Yep. We'll put everything in the description.
Sure. And you're welcome also to email me or contact me through LinkedIn. I'm here.
Assaf Wise, love what you're doing. Thank you for being on IsraelTech.
Thank you.